All right, let's go back now to the exercises that involves waves. This is the exercise that includes topic 4.1 and topic 4.2. All right, let's start. The work done to move a spring away from its equilibrium position is equal to A, B, C, or D. If you're going to look at the choices, you will be left with the most possible answer, kinetic energy or the potential energy. But if you're considering kinetic energy, you know that the formula for kinetic energy is equal to 1 half mv squared. So basically, you're getting the V here. But for potential energy, you're looking for 1 half kx squared, and you're considering x, which is the amplitude or the displacement from the equilibrium position. So the correct answer here is letter D. Next, you have A, B, C, D. You have a graph below that is a plot of displacement versus time of mass oscillating on a spring. So, at which point on the graph is acceleration of the mass zero? If you're going to look at it, this is A is directly proportional to the negative of displacement. So, at A, you can see here that this is at the maximum. Let me just draw the graph for you to visualize this. This is A. This is the equilibrium position. This is the negative, and so on. Let me just draw the mass spring system. So as you can see here, the evident one is A, and then this is C. Because this is negative. Alright, so this is B. Somewhere here. And okay, this is D. Somewhere here. Alright, at which point on the graph is the acceleration of the mass zero? So at this point, we say that the acceleration here at C is zero. Why zero? Because we know that acceleration times mass is equal to the force. And you know that force is equal to negative kx. Because x is zero, referring to the equilibrium position, then that means that force is zero and thus acceleration is also zero. So the correct answer here is letter C. At which point on the graph is the net force on the mass at the maximum? So you're looking for the net force that is at the maximum. The correct answer there is letter A. Why letter A? Because you are considering the amplitude here or the delta x here. Next, at which point on the graph is the velocity of the mass zero? So, where is the velocity here that is zero? The correct answer here is letter A. At this point. Where is it the maximum? At this point. At C. At the equilibrium position. Alright, next we proceed. Transverse waves vibrate blank to the direction of the wave propagates. We already understand this, that transverse wave vibrate perpendicular to the direction of the wave propagates. How about for longitudinal? The longitudinal vibrate parallel to the direction of the wave propagates. Next, a wave carrying a larger amount of energy will have a greater amplitude. Remember that the greater the amplitude, the greater the energy. Let's take for example like a water wave. Of course, if it has a greater amplitude, a greater area, then that means that it has a greater energy. Explain the meaning of the negative sign in the Hooke's law. Remember that the Hooke's law has a formula of F is equal to negative kx. The sign negative here, the sign negative is because the force is always opposite to the displacement of the spring. Alright? proceed. Which describes a sound wave? A sound wave travels in a vacuum. No, it cannot travel in a vacuum because light can travel in a vacuum because it's an electromagnetic wave. But sound wave is not an electromagnetic wave. Sound wave is an electromagnetic wave. It's not. It's a mechanical wave. That means that it requires a medium to travel to. A sound wave has a one constant speed. No, not really. It's not like speed of light that has 3 times 10 to the 8 meters per second. Sound wave is a longitudinal wave. This is the best answer. Letter B. What is the formula for to find the speed of light? The formula for speed of light is equal to V is equal to F lambda. However, in this particular case, V is equal to C. C is equal to F lambda since you're looking for the speed of light. So the correct answer here is letter B.